So we're going to start our biochemistry of life unit by looking at the properties of water. As you know, water covers a majority of Earth and makes up 85% of all living things. A water molecule itself is, as we know it, is H2O. It's made up of 3 different atoms, 1 oxygen and 2 hydrogen. They form almost what looks like a Mickey Mouse face. So in your note packet, please label the top 2 ears of Mickey Mouse as hydrogen molecules and label the larger atom the oxygen molecule. Water itself is polar. And so what does that mean? In each water molecule, the oxygen atom attracts more than its fair share of electrons. The oxygen end then acts negative. The hydrogen end acts positive, creating almost a magnet effect. So this is what causes the water itself to be polar. Now, water itself is neutral. When we test it, it does not have a charge. It's not acidic, it's not basic because of any ions, because there's an equal number of electrons and protons. This is what creates the zero net charge. So, what does this do for water? The hydrogen bonds that typically form between the electronegative atom of a polar molecule and the hydrogen atom. So that's going to exist right over here with the oxygen atom and right here with one of those hydrogen atoms. So do me a favor, check out in your note packet. I have those ends labeled for you, but notice how the oxygen side is labeled negative and the hydrogen sides are labeled positive. One hydrogen bond is weak, but when many hydrogen bonds form, it creates a strong force. So, the negative oxygen end of one water molecule is attracted to the positive hydrogen end of another water molecule to form that hydrogen bond. So what exactly are the properties of water? Why do we need to know about this hydrogen bond that forms between the water molecules? Well, at sea level, pure water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. Now, I'm sure that wasn't anything new for you, but the boiling temperature of water decreases at higher elevations because of the lower atmospheric pressure. For this reason, an egg will take longer to boil at higher altitudes, in case you ever decide to move to Colorado. Now, one of the properties of water is known as cohesion. If you think about how that word is divided up, cohesion. Co means, the suffix means together. So you think about the word cooperate, and that means to work together. While cohesion is one of those properties of water. Now there's what's called adhesion, and that suffix ad means different. So we know that water has a very high specific heat, it has a high heat of vaporization, and it is less dense as a solid, which is why we saw that picture of the iceberg floating. So exactly what is cohesion? So the attraction between the particles of, cohesion is the attraction between particles of the same substance. This is why water is attracted to itself. This results in what we call surface tension, a measure of the strength of the water's surface. This is one reason why we can see sometimes a surface film on water that allows insects to walk on the surface of the water. So those water spiders, sometimes we see water snakes that are able to stay on top of that surface tension. So here are some examples in case you haven't seen that in real life. I think they're pretty cool. They can move pretty fast on top of the water too, I'll tell you what. Alright, so adhesion is the attraction between 2 different substances. Water will make hydrogen bonds with other surfaces, like glass and soil, plant tissues, and cotton. Capillary action is when water molecules will tow each other along when in a thin glass tube. One example is transpiration. Now, we studied transpiration during the water cycle, but remember transpiration is like perspiration for plants. If they're releasing water in order to keep cool, where does the water come from? If you think about it, it has to move from the soil through the roots, up through the stems, and if it's a big tree, boy, it's got to move all the way up that trunk, out all those branches to all the leaves in order to evaporate. So how exactly does that work? Well, you know how you see those Bounty commercials and they have the quicker picker upper? Well, the quicker picker upper is demonstrating capillary action. If you spill some water on the lab table and you hold one of the brown paper towels up to it, you will see the water rise up the paper towel. Okay? I want to give you an example of adhesion too before we change the slides. Adhesion, a good example of adhesion is when you take a pop can out of the fridge, right? It's really cold. When you take that pop can out and you bring it into a warm environment, say it's a nice hot summer day, what do you see on the outside surface of the can? Hopefully you see condensation, and that's water vapor that's condensing on the surface of the can because it's so cold. Well, the reason those droplets of water remain on the can is because of adhesion. It's attraction between those water molecules and the aluminum of the can. Now, once the water gets too heavy, once that droplet has too much water condensed, then you see it drip down the side. Cool. So adhesion causes capillary action. So when you stick a straw into water, you typically, or into another substance, you typically see the, you typically see that solution climb up the inside of the straw. Adhesion also causes water to adhere to different surfaces, causing droplets. So when it's rained or it's really humid outside, you can see droplets of water attached to a spider web or to the surface of plant leaves and kind of dangle there in like that perfect sphere. So let's talk about the high specific heat of water. This is the amount of heat that's needed to raise or lower 1 gram of the substance by 1 degree Celsius. Water itself resists temperature change, both for heating and for cooling. Water can absorb or release large amounts of heat energy with little change in actual temperature. So let's look at the high heat of vaporization. This is the amount of energy to convert, sorry, it's not coming up there, 1 gram or a substance from a liquid to a gas. So in order for water to evaporate, hydrogen bonds must be broken. As water evaporates, it removes a lot of heat with it. Can you think about how that works with your own body? When you get hot and you perspirate, as the water evaporates off your skin, that takes some of the heat away and it prevents you from overheating. Water's heat of vaporization is 540 calories per gram of water. In order for water to evaporate, each gram must gain 540 calories. The temperature itself doesn't change. It still remains at 100 degrees Celsius. But as the water evaporates, it removes a lot of heat with that cooling effect, like I was saying with perspiration. So water vapor forms a kind of global blanket which helps to keep the earth warm. The heat radiated from the sun warms the surface of the earth and is absorbed and then held by the water vapor. Now, we all know that water is less dense as a solid. Ice is less dense as a solid than as a liquid. That's why ice floats. Liquid water has hydrogen bonds that are constantly being broken and reformed. Frozen water forms a crystal-like lattice-type structure whereby the molecules are set at fixed differences. And I apologize because I know you can't see the fixed distances at the bottom very good, but it's in your packet. Now, which one of these is ice and which one is water? Water is less dense as a solid, so hopefully you identified the picture on the left as water and the picture on the right as ice. Notice how you can see spaces in between the molecules. and it's very, very organized in terms of the pattern that's being produced. That's that lattice-like structure. Notice how water is much more unorganized in terms of its arrangement. So what does this mean for us? One of the characteristics of life is the fact that we can maintain homeostasis. And homeostasis is the ability to maintain a steady state despite changing conditions, whether those are in the environment or within the organism. So water is important to this process because it makes a good insulator. It resists temperature change. It is a universal solvent, meaning you can you can ingest all sorts of things and it will dissolve in the water in your bloodstream and your body will still transport it to all of your cells. It helps act as a coolant for your body. And the ice can actually protect against temperature extremes. So in the winter, it insulates frozen lakes. That's why the fish don't die. So let's talk a little bit about the difference between solutions and suspensions, mainly because part of our biochemistry unit, as well as some of the information we're going to learn about cells, has to do with solutions. So water itself is usually a part of a mixture. And so there are two different types of mixtures, solutions and suspensions. Now the solution itself is when ionic compounds disperse as ions in water. They typically become evenly distributed within the water. A solute is the substance that's being dissolved. The solvent is the substance into which the solute is dissolved. So one example is when we take salt and put it into water. Salt is NaCl, sodium chloride. So when the sodium chloride goes into the water, the sodium and the chloride ions separate. And as they separate, they disperse throughout the water. And you can see that there are water molecules that then are attaching close to the chloride ions. Okay? You can see a sodium ion over here. There's water being attracted to the sodium ions. So that's what helps disperse the salt in the water. Some suspensions, oh wow, I'm getting ahead of myself. Let's define it first. Substances that don't dissolve but separate into tiny pieces is what's called a suspension. It's other compounds that are floating in water. So water keeps those pieces suspended so they don't actually settle out. Two examples here are milk and mayonnaise. Mayonnaise, you gotta love it, or other people just hate it. I'll tell you what, my husband hates mayonnaise. All right. So that's the end of our unit or our notes for water. So we're going to be doing a couple of different activities studying water to learn about adhesion, cohesion, capillary action, and I think that's it.